So welcome back, NCEA Level 1 physicists, continuing on with mechanics external by looking at the concept or idea of pressure. So pressure is the amount of force applied over an area, force divided by area, where force is in newtons, the area is in meters squared, and the pressure is in pascals with the units of capital P, lowercase a. So just like our previous equations, you can also create a magic triangle when you can rearrange the equation, okay, which you could have to do in the exam. So force also equals pressure times area. And again, if you rearrange, area will equal the force divided by the pressure. I also point out that 1 pascal of pressure is the same as saying you've got 1 newton of force being applied per square meter. So newtons per meter squared. So here are just some examples of pressure. So the pressure in space is 0 pascals. The air pressure on top of Mount Everest is lower than it is at sea level, so it's 30,000 pascals, where at sea level, where we are at the moment, is 101,325 pascals. A typical tire has a pressure of around about 180,000 pascals, okay, so about twice the pressure at sea level. And pressure 10 meters below the surface of the sea, so when you go diving, is about twice that at sea level, so 200,000 pascals, whereas the estimated pressure where the Titanic is, about 3.8 kilometers below the ocean surface, is 41 million pascals. So obviously you can't free dive down to the Titanic due to the massive pressure associated with the water exerting a force on the Titanic. So a common question in exams usually involves tires or snowshoes, similar things. Okay, so you can see with monster trucks and tanks, the reason why they have big tires or they also have tracks is to increase the area. Okay, so they want to increase the contact with the ground. The reason why is that you'll want to reduce the amount of pressure. So as area goes up, the pressure goes down because the weight vehicle is about the same, okay, and that means they don't get stuck in the mud. Okay, that's the advantage of having lower pressure. So analogously, this is the reason why you have studs in rugby boots, because it's a small area, so therefore the pressure per stud is greater, so that way you get more traction on the muddy rugby field. Okay, so this is kind of an opposite way of looking at the concept of pressure and how you can increase and decrease pressure. And finally, just looking at how gases exert pressure. So as we know, a gas consists of molecules all bouncing around in random motion. Okay, and when a molecule collides with the surface of the inside of the can, it's going to apply a force on the surface. Okay, and it's going to be over an area. So that means that the faster, for example, the particles are moving, the more force it applies. So that's why when you heat a can, the inside pressure increases, okay, because the total force being exerted by the molecules is going to be increasing, yet the area stays the same. Okay, so that's the ways how a gas can exert pressure, say, inside a can. Okay, so that's today's lesson in pressure.